we'll be able to see the recording. So the recording is now running. So welcome to all the recordees as well. So again, thanks for attending today. This is, as I said, a new format. I'll be the main presenter today. Don is actually with me, Don Larson, but he's going to remain in the background really as what we describe as a panelist. So he's going to look out for your questions or comments, and then we'll actually try and answer those or comment on those as we proceed through the webinar today. So let's just go through some housekeeping. It's the usual webinar housekeeping rules. The only thing that we're kind of different today is that we will unmute a delegate if they want to raise a hand and make a comment. So if you do want to say something, it's not compulsory, but if you want to say something, then just raise that hand, and we'll be keeping an eye on that, so you can make a comment. You can also use the questions box down here to make comments and ask a question if you wish. And again, I'd encourage you to do it during the webinar today rather than at the end. We're not going to kind of have an end Q&A. We'll just try and kind of deviate as we go along. We've got some handouts that you'll be able to drag and drop over to your computer at any time. And obviously we will follow up. You'll get the link to the recording and other information probably tomorrow. Just in case you're not aware, Larson Software Technology is based in Houston, Texas. We've just moved into a new location. Well, it was earlier this year, or was it last year? I can't remember now, but we've not been there very long. We developed graphic software and toolkits, so off-the-shelf and software development kits. We were really the main company, I think, that promoted the usage of CGM. So to do that, we provided a free viewer, which we then changed because of the upkeep of it and the maintenance of it. We changed that to a subscription version a couple of years ago. So that can be purchased through the online store. It's like only $48 to subscribe for a year. But it's a useful tool if you just need to view CGM files. We also developed a HTML5 viewer for CGM. This was really a reaction to what happened when plugins became kind of security risks like ActiveX and things like that. So we developed a plugin for CGM, a viewer for CGM that will run native in HTML5. So that's been really successful, and we continue to develop that. So we also work in other industries or sell to other industries like engineers in manufacturing, geologists, geophysicists, and that's where the company actually started with CGM many years ago. So the agenda, as I said, it's a slightly different format. We encourage you to kind of take part if you wish. It's not compulsory, but we would like some feedback if you can provide it, or a question if you're not understanding what I'm saying or I'm not talking sense. So the topics we want to cover in this particular episode really is converting and also deploying 3D data. So we have our own kind of ideas on this, but it'd be good to hear somebody else's, somebody in the industry as well, doing things live. So we're going to talk about converting 3D data to 2D, which is not a new thing. You know, it's been around for some time, taking advantage of 3D models within the organization that you're working with. But also we'll want to look at deploying 3D data. So I think this is actually newer, although again, it's been done for a while, but I don't think on a large scale. So it'd be good to discuss that to see if we're on the right track, if it's something we see that companies are beginning to use or not. Okay. And then we'll have a summary, and then we'll talk about the next episode, which will be in a few weeks. So some of the terminology, there'll be lots of terminology. I don't want to kind of blind you with too much jargon and things like that, but you'll hear things like X3D, CGM, which you probably all heard of, IGES and STEP, and other kind of native CAD formats today. So if you're not sure about anything that we're talking about, if it is jargon, if it's an acronym you don't know, then just put that in the comments and we'll try and answer that. So as I said, this is the first event in a series. If we continue it, we'll just gauge the success on the people that attend, if they've enjoyed it, if they want to change the format in any way. But it's the success we'll gauge if we do more. I think it's an idea for illustrators to have their own forum. It's not something that I've seen before very specific to illustration. I think there's a lot around XML and data and all sorts of different things, but nothing really much around graphics. So technical illustration, it really has some very specific requirements as opposed to text, and I think we all know those. And today we want to discuss the current use of 3D data in technical illustration, and we want to focus on the conversion and display. So as I said, please ask questions, make comments at any time. We're pretty fluid. I do have slides because I want to obviously make it. I can't just sit here waiting for things, so I want to try and give you things to think about and then perhaps comment on. If you don't know, I'm originally from the UK, which you probably detected from my accent, and I usually was trained as an illustrator. Went to college, learned illustration, studied illustration many years ago. In fact, before computers. So I've kind of seen the whole thing evolve. So I have a background in the discipline of illustration. So I think I'm qualified to actually talk about it, hopefully. So hopefully that gives you some kind of comfort that we know what we're talking about. So I think the ability to reuse 3D data is increasing. I'm not sure that's true of there's a lot of CAD data out there, and there has been 3D CAD data for some time. So I'm thinking it's increasing because perhaps we're beginning to reuse it in different ways, perhaps to display it as part of a technical manual. And I think it's also readily available within many companies. They might be using CATIA, Creo, and PTC, SolidWorks, Inventor, and there's others as well. I'm just cherry picking probably the main ones that you've heard of. So, but obviously, if we go back in time, there wasn't 3D information available. Everything was done 2D from engineering drawings, flat engineering drawings. So there's a lot of legacy that perhaps will never have a 3D equivalent. So, and that's something you've also got to remember and focus on, is that there's a lot of legacy that still needs maintaining. So we always kind of focus on that we want to still provide the best tools for 2D as well as 3D. But I think a lot of the challenges for illustrators and publications departments in general is choosing the right file format to use to repurpose data. And that could be any 2D, 3D, could be anything. So, this is something that we've focused on, giving as many file formats as we can for the end user to use either 2D, and now we're moving into 3D. So, and this is why we want to kind of run these forums to try and get feedback from actual users to see what they want to see in our products, but also in the market in general. So probably all of you on this particular event have heard of CGM. So it's been around a long time. It's just because it's old doesn't mean to say it's not good. So it's got to a point where you can't really develop it anymore. So it's very stable, it's very robust, and it's still the chosen or selected format of, say, the ATA and S1000D. So CGM is not going to go away. It's going to be around for a while. So it's important that we keep developing our tools to support it. SVG is, again, it's been around probably longer than you think, but it's really grown in use, and we've recognized this ourselves, really because we've been driven by customers to have a good support for SVG. And that's because, again, the viewer the viewing of CGMs became more challenging within web environments, and SVG is native to HTML5. So, and a lot of companies changed to SVG, but hopefully only for display, because it's kind of limited as an interchange format. It was really not designed to data exchange. It was really designed just to display in a web environment. So if you're going to convert from 3D information to 2D, then it's important that you can still support CGM and SVG. So if you're coming from a CAD system, then that could be a challenge, because a lot of them don't support CGM. If they do, it's probably a very early version of it. And again, SVG is probably not common output format from CAD systems. So at some point, you're going to have to get it probably into this format. So that's a consideration when you're actually converting 3D CAD from a CAD system. That what's my target format? What format do I need to get it into? As with any kind of data exchange, there's usually always open formats that are not owned by a company, that are in the kind of public domain. And in CAD, there's STEP and there's IGES. I think those are the main two that are good for really containing 3D data. So, and I think STEP is probably the preferred format now. It's a really recognized data exchange format for CAD systems. So usually a CAD department will create STEP files as well as native files as well. So, and we've been working with STEP especially, and found it a really good, reliable format. The other option is for data exchange is the native CAD formats. But that becomes more problematic, because if you're going to convert them, the conversion has to be either done by the CAD system itself, or if you're going to use the native format in something else, then it has to support that format. So you could think that that's the optimum data exchange scenario, but it probably only applies if you're exporting from the CAD system itself. So I think really STEP is a really rich format. It's a great alternative. So we have some polls. I'm going to try and run a poll at this point. And let me just bring it up. And launch that. So if you want to quickly vote on, you can actually choose multiple answers. So you don't have to stick. You could be using different formats. You might be using no format, but I just kind of encourage kind of everybody just to vote, and then we'll get a gauge for the audience, what you're using, and I think it'd be useful information for us all. So let me just close that. I'm not sure how this is going to. I think we've got pretty much everybody's voted who's on. I'll just give you might be one person who hasn't, but if you're not using any of them, don't worry, or you're not watching. So I'm going to close that down. Okay, so I'm hoping you might see the results, but if you don't, then I can tell you that 80% STEP, 40% IGES, 60% CATIA, and 40% SolidWorks, and then 20% others. So that's pretty interesting. I'm encouraged to see STEP, and obviously people could have voted in both categories, but I'm encouraged to see STEP is 80%, because that's one of the formats we've been focusing on. So pleased to see that. So thanks for your input. All these are, we don't see who's voted for anything, so don't worry either. It is anonymous. So. Okay, so 3D conversion software available. So this is, if you're going to convert from 3D to 2D, then you're going to need some mechanism to do it, either the CAD system, a specialist solution. We've just developed our own PhysX Edit 3D, and then there's the CAD system itself. The CAD system itself could be doing the conversion. But what we found, if you're converting from a CAD system, then definitely quality could be an issue because they're not really designed to kind of optimize themselves for illustrations. There's also quite a lot, if you do some investigation, 3D viewers out there, which are really some really good tools out there to manipulate a 3D model. But again, the challenge is usually the output. What kind of formats are outputted? They may be limited, and the quality might not be very good. So there's kind of lots of ways to get 3D data into 2D. But I think from an illustration point of view, we want to optimize that as you know, somebody who's like an illustrator wants to provide the best quality to the end user or to the company. So we want to try and keep away from producing poor quality from good quality, because in the CAD system it's vectors, so we don't want to degrade it in any way. By the way, please just drop anything into that question bar, if it's a comment, if it's a question, and you know, don't be. I know I'm talking continuously, but if you just get time, just drop something in there, and I can always deviate away from what I'm saying. So yeah, quality of the 2D output. You can have different impacts, really. I would certainly not encourage the use of image formats like TIFF and JPEG. You know, you don't want to lose the vector information that you've kind of carried over from you can carry over from the CAD system. And the other thing, even if it's vector that you're exporting, then you have to be careful that even the vectors can be poor quality, because like CAD systems can generate what we call polylines. So a curve could be represented by very small straight lines. So that has a compound effect. One is that it's very difficult to actually edit because you've got little straight lines rather than, say, a Bezier curve. And then secondly, it can, because you've got so many points, the file size increases. Then that, if you want to then put that on the web, for instance, in a viewer, then the bigger the size, the longer it takes to load and render and so forth. So file size can be an issue as well. So just some conclusions around conversion. We think you really want to use the right solution, something that's designed to do it. So if you've got access to the CAD system, you should be able to get something reasonable out of the CAD system, but you still might need to use another tool to finish it off with annotations or hotspots. So so you have that ability, but only if you have access to the CAD system. So if you haven't got kind of a CAD seat that you have access to all the time, then you know you're gonna have to find something else. As I said, quality is important. You want it easy to edit and revise, and you want to retain a small file size. If you're working to a standard such as S1000D, you'll also need that ability to resave that as a CGM file at some point. So that's still that's again crucial. So even if you're coming from a 2D CAD format like DWG, you might need to resave it as CGM to meet the specification that the company is required to meet. So is there any questions or comments? That's the kind of first part of the presentation done on conversion. I'd be interested to know if you've experienced any issues or issues that you might experience that I've not pointed out there when you've converted 3D to 2D. If you want to say, if you've got a tool that you use that's very good, then anything really that you want to say about conversion, this is a good point to actually ask us. I don't think there's anybody raised their hand yet, so we're not going to open the mics up at this point. But, let me just quickly double check that. I know we've got Don Larson actually checking that as well, so. But nobody's raised their hand yet, so okay, that's no problem. It's not, as I said, it's not compulsory. So the next part I want to move on to is deploying and displaying 3D data. And I think this is beginning to grow, although I've been saying this for years. But I think we might be actually getting there, finally. But not to a great extent. I think 2D is still going to be the main way to create illustrations and deploy them. But this topic, hopefully it raises many questions, because it'd be good if we got some questions from you. So what is the benefit to the end user of 3D information? So I kind of wonder this: is it useful, or is it something that they just get distracted by? I'm not really sure. What type of technical information lends itself to 3D delivery? Is it maintenance, repair? Is it operator instructions, spare part illustrations, assembly, disassembly? What's the cost to create that information? You've already got it in the CAD system, but then you're going to have to reauthor it in some way to make it more viable for a technical information or technical documentation. So what's the cost to then actually add more to it? Is there hardware and software available to deliver the information effectively? It could be that the files are so big that none of the hardware we have is able to present it. And what file format should we use to do this? Okay, so I kind of answered my own question a few minutes ago, and I sometimes think it's a really good idea to use 3D data and technical information. Then I think, could the user just be distracted by it and start spinning the model around and not really doing what they should be doing? So I think it's useful in the respect that we can improve the recognition of component parts. I think it's useful if we're going to be doing assemblies and disassemblies. These could be animated, or that just pulls the part away from the main body of the system and shows you what order we need to do. So hopefully this just appeared on your screen. So this is some of the work we've been doing around 3D. And the good news is, if you're a user with VisX Edit Plus, we're actually going to put the 3D viewer into that product. That's just the viewing part. If you want to convert, then you'll have to use VisX Edit 3D. But if you just want to view a model in Step or IGES, you'll be able to bring it into VisX Edit Plus and just have a look at the model. And you should see the tree. You should see the assembly, the tree viewer, and you'll be able to click on parts. But this is kind of like, if the guy in the shop floor wants to look at this, or the end user, and they want to spin it around, it could be just a distraction, perhaps, from what they're trying to achieve. But again, it's useful if you want to look underneath and see what's there. It's also useful if you want to pull a part away. Let's just say if I want to pull this part away from here and see what's behind it, then that would be useful for the end user as well. And if we wanted to do disassembly, we might want to pull these bolts apart down here and animate that, perhaps. So I think there's definitely a use case out there for 3D. But again, you have to kind of bring it into the publication, actually. Yeah, somebody's just asked me about delivering 3D models for VR and AR. So that's virtual reality, augmented reality. It's not something we're doing currently, and not something I've got a great experience around, unfortunately. I think it's something that we'll see appear more and more. The tools are improving around that space. We've been looking at one particular provider, which I've got a link to in a second. But there's HoloLens and things like that. And this is, again, not new. This was looked at years and years ago with computers kind of strapped to people, and it didn't really get adopted. very much. But I think now perhaps the tools are improving with glass type devices, head-up displays. I know kind of PTC are heavily into this area with their tools, but again, the adoption of that will be dependent on cost, on what programs you're running on. What's the benefit to the end user to do that? Perhaps it might be the delivery of something like a 2D almost manual on the lens, so you don't have to refer back to a computer or an iPad, that it's just presented on your kind of a head-up display. So, in fact, yeah.
Yeah, excuse me, David. I think we have another question too from Andrew.
Yeah, let me see if I can. Andrew, I'm going to open your mic up. So if you want to, let me just do that now. I think I can unmute you. Let me. Interesting. So I'm trying to unmute you, but it's not letting me. Right, okay.
There we go. I think I'm on.
You're on. Yeah, I can hear you. Thanks, Andrew.
Okay. Sorry, my raising of the hand was a little slow there. Sorry. One of your previous slides, you spoke to the different types of information that could be enhanced by having 3D models.
Yeah.
A lot of times when we receive either there's something posted on the web for perfect, that's exactly the slide I was speaking to. Either one, you're working with a government entity where you're being sourced for information, or you might be responding to a return for an ROI on a website. There's going to have to be some communications with the end user or the customer as to what their requirements are, because sometimes they say globally, oh, well, we want 3D models used.
Yeah.
But then you need to define exactly where do they have their expectations set. And so I just wanted to, I didn't really have a question, but I had just more of a statement that at some point you're going to have either pre-negotiations before you send in a ROM, or you're going to need to have post-negotiations after they've sent you already scripted tech manual contract requirement, something like that, or a statement of work, so that you can have that agreement as to the expectations.
Yeah, completely agree. This is it's kind of not easy to define. It's easy to define a 2D illustration, and what it should look like and the procedure, but then to define it in 3D, what viewpoint do you need? Do you need more than one viewpoint? Does it have to connect to a procedure? If it's a repair, does it need to connect to procedure with different steps? What are the steps that are probably already defined by the author or the writer? But yeah, this is why I say it's not. I think sometimes people have shied away from it because of the reason you've just said, is that it's like a requirements document all on its own, just for an illustration. So
exactly, and I've had customers where they've globally said use 3D models, but then when they get to the point where you've made something for a maintenance procedure, they're not so sold on the fact that the maintainer can move the model around, because they'd rather have one camera angle, so that the maintenance procedure isn't lost if it's animated or anything like that. So they might like the 3D model for an IPD because they can turn it around, they can see all the parts and that kind of thing, they can rotate it. But when it comes to a maintenance procedure or an operator procedure, they're a little hesitant to have that.
Yeah. Okay, I appreciate Andrew, you coming on. Thank you for doing that. I don't know if I can.
Thanks for entertaining me.
Okay, I think I'm going to mute you again. So thanks, Andrew, for that input. I'm just going to, and thank you for the question around the AR. Yeah, I think we're trying to kind of run at the moment with 3D. So I'm not saying walk, I'm saying run, because we feel this is important. But I think AR and VR, it's almost it's something that we need to look at as an organisation. And there's lots of solutions out there. There's this particular company called Vuzix that have the kind of the glass solution, which is kind of handy if you're in the field and so forth for getting documentation if you're in situations that don't lend itself to perhaps an iPad. So yeah, definitely we are interested in this area, but perhaps not as much with the 3D. We kind of as a first starting point, would like to be able to show 2D in these solutions. So in other words, if they need to be hands-free, then they can view perhaps a CGM, even like a 2D CGM. And plus, I think it's the big organizations that are really involved with AR and virtual reality and augmented reality at the moment, with kind of big budgets, who can go out and do these prototypes and so forth. But it doesn't say we're not aware of it, and but certainly we don't have a lot of the experience required for that area at the moment. So, well, just speaking to Andrew about kind of what types of illustrations, I really see you mentioned spare parts, and I think for some time there has been certain companies who have been able to give you 3D spare parts manuals, and it's something we would kind of aspire to as well, but in the right way. But I think with any of these 3D things, it's difficult to calculate a return on the investment. If you're a service provider, then it's quite easy, because somebody's coming to you with that requirement. But if you're the company itself deciding, like, well, we want to go 3D, what's the cost to do that, and how are we going to get a return on that? And certainly in technical publications, that's always difficult to see. It's always seen as kind of this overhead, rather than something that makes any money. So I think with what we've got here is a market that is still kind of moving, and we need to get the right tools to do this. So this is I actually found this little app. It's not something you can buy. Well, you can get the app, but it's not software you can buy. But it's what these companies are doing is partnering with this organization to actually put 3D instructions onto iPads and so forth. So they kind of tend to be like home things, like grills and things like that, where they can just they've got 3D, but it's just like an instruction rather than a paper manual that you get. So I thought that was quite an interesting kind of concept. It's got definitely a link to illustration. I'm not sure how they're doing it, because it's not something you can download as software that they're selling. It's a service really that they're selling to these kind of suppliers. But it's interesting that people are beginning to use 3D in this kind of way. So that's builtapp.com. You can actually download the app from the Apple Store. It doesn't cost anything. But obviously you need some equipment to use. I don't know if they do a sample or not. To me, the biggest benefit I could see with 3D is to perform a complex procedure. You might not want to do every procedure, but something particularly complex where the cost of a mistake could be, it could be very expensive. Say an expensive part, say on an aircraft, gets damaged because there was a mistake made with the procedure. Then in that case, you've got like a good business case to actually develop a 3D simulation of that. But then you could also argue, why don't we make a video of the same thing? We could use a video, somebody, and actually the maintainer doing the thing on video. So, nowadays that's a lot easier with phones and the quality is really good. So it's interesting that I suppose the thing is, if the procedure updates, you then got to go and re-edit the video, but if it was a 3D file, you might just have to modify one of the parts. So I don't know. It's there's different scenarios really that could apply. The other big question is, what's the cost to actually author this data? And that's what I was saying. I mentioned business case and things like that. Is that somebody's going to have to calculate what the return is. You know, is it going to be a return, perhaps not in money, but actually in support? You know, our support goes down because we've got much better information we're giving to the maintainer or to the end user. You know, he's not damaging things, he's not losing things. He can identify things quicker. You know, things that might go into the supply chain, so logistics. Cost decrease because it's ordering the right part rather than the wrong part. There's also the cost to train, you know, the illustrator perhaps to use the software, the cost to maintain and revise the information. You know, is it going to cost more to do that over a traditional 2D? And the cost to deploy it, you know, which is usually a customer issue. You know, have they got the right device to do it with? Have they got the devices at all? So a bit of a jump, a bit of a leap there, but we think this is one area that's been neglected a bit with 3D is what formats to use. We would always kind of, because we kind of always promoted CGM, which is an open format, we kind of want to keep that direction in 3D as well. So for display, these aren't really interchange formats from the CAD system to convert. These are really for displaying. So X3D is something we're really interested in. It's an XML format. There's PRC, which you really see within PDF, so 3D PDF. And then there's U3D, which just seems to have disappeared a bit. And there's also VRML. So VRML's been around, you know, like CGM for a long time. And it's a nice format. It's a markup format. So it has a text structure to it. It's quite a light format. It's good for doing 3D interactive graphics. It was designed for the internet. However, it does usually need its own specific viewer. So, and these viewers would obviously be able to go view these on the web and so forth. But yeah, I think it's got its limitations. And it's now really been superseded by X3D because you can convert VRML to X3D. With X3D, you get the XML. So with XML, it really gives you style sheets, a lot of validation, gives you a lot more options than VRML does. So X3D, as I mentioned, it's XML. Really, we will have that ability to have a schema for it, so you'll be able to validate files. There's no plugin required if you want to view it in a web browser. Let's see if I can just bring up a file here. Okay, so this is running without, is running with no plugin. You can click on parts. Just zoom back out. You can see that we get, whoops, it's not quite that easy to handle this. So you get parts, a tree, you know, a bill of materials. We can interact with it, and we're all running. It's pretty quick. We're running without any plugin. So I think this is, to me, is an attractive proposition for getting 3D data out there, because everybody's got a web browser. Well, virtually everybody. So that's one of the reasons we're kind of looking at this particular format. Okay, so the question is then that was just viewing the models, but so if you wanted to use it in a technical illustration environment, you need to be able to author it in some way. You need to add interactivity and animation and hotspots and perhaps step through things. So you're going to need a tool to do that. We haven't really found one at the moment. But in saying that, it's XML, so you could actually do it. It is possible to do it. So possible to have hotspots and so forth. So I think it's quite an exciting thing going forward, and really removes that kind of reliance on native formats and installing viewers and so forth. So just a quick comment on S1000D, if that's one of the things that you have to comply to as a company. We're going to cover this, and then we decided on the next Talking Technical Illustration, we're going to look at S1000D. But as far as 3D is concerned, it's very kind of brief. They don't specify any format, so you're pretty much free to use any format. What they do specify is the use of color and things like that, and warnings and cautions and so forth. So in theory, is to comply, you have to add certain things to the 3D content, but there is no particular file format you really need to use. But we would also always recommend something that's open. And I'm surprised they haven't done that. That was a bit of a surprise. So conclusions, will the user have to install a separate 3D viewer for displaying? Could be IT issues. Use the correct file format, not proprietary. That's our stance. You know, something compatible with HTML5, hopefully. Then you don't have to install a viewer. Think about file sizes. You know, this is pretty crucial if you want to load this 3D model into, well, an iPad or any other environment. You know, you don't want to frustrate your end users. And is this kind of question is open? Is 3D the future of technical illustration? I tend to believe it is, to be honest, but not for everything. You know, we're going to have to maintain legacy like for many years to come. So if you've got any comments and questions, please post them. We're really welcome. You're really welcome to do that. If you like the event, you can't give me a thumbs up, but you could say you like the format. You'd be interested in other webinars in the future with this particular format. We're going to try and make it more interactive. I think actually I missed the poll out. We actually just run one more poll before we go. Sorry about that. So this is a poll for to see if you're actually using 3D now. So let's just launch that. So I think it'd be a good thing to end on. So I hope if we've got anybody left, I think we have. So it'd be good if you could just take a few minutes just to vote on that, to give us some feedback. So you should see it, and I'll begin to hopefully see some feedback. Okay, got a few more people to vote. If you don't use it, obviously you're not going to vote. Okay, I think I'm going to. We've got virtually everybody, so I'm going to close that off and we'll look at the results. So, interesting. 25% spare parts, 50% maintenance procedures, 25% assembly instructions, no operator instructions. That's interesting. I would have thought about there being more operating instructions. But anyway. Thanks again for your input for the poll. Please don't remember to do it. So let's just go back to the summary. Yeah. So we hope you enjoyed it. If you've got anything post webinar that you want to send to us via email, then please do. In 2 weeks, I think it's going to be 2 weeks. We'll have episode 2, compliant to technical illustration specifications, S1000D. We're going to release the details of that on Monday. So we can, if it's something that you're interested in, we hope you can join us. So I'd just like to thank everybody for attending today. It's I think it's been good. We'll certainly be doing episode 2. So please attend the next one if you have time. It'd be great to see you again. So thanks for today, and stay safe. Thank you. Bye-bye.